begin, we're going to give you an executive overview of basically what our product is, a quick brief review of the requirements, show the updated hardware design, updated software design, the current timeline, our future tasks and possible implementations, and we'll finish off with questions. So just to begin, Euphony is the first ever Wi-Fi GPS-enabled portable music management system. It was designed to free music storage space onto a compact portable device with some form of expandable memory, in this case, which is a micro SD card. Now, Euphony uses Wi-Fi to connect to its own music library app where songs are synced locally, and this will allow the user hours of music playback without ever having to worry about cellular data overages or memory usage on their smartphone. Now, some of you may be wondering why GPS? That's a great question. So, with Euphony's small hardware that has a keychain application, we wanted to utilize GPS in case the device was ever lost. So therefore, the device systematically pings to the app, which allows the user to ever find their device if it is lost. So just a quick review of requirements. As I mentioned, the device shall use GPS to ping the location systematically. The device shall communicate with the smartphone using Wi-Fi. The device shall use some form of expandable or removable memory. The device shall use a battery that is rechargeable by the user. The device shall be able to play continuously for at least 4 hours. The device shall come with the music library app, where music can be accessed locally. And the device shall be small enough where it can be used as a keychain or wallet insert. So just team member tasks. As I mentioned, my name is Naife. I was the HMI developer, the iOS developer, and acted as a hardware component researcher.
I'm Sean. I was the hardware design lead, essentially, and I did the circuit and the PCB design.
I'm Suvro. I was the software architect, and also I made the Android app and wrote all the Intel Edison, which is our microprocessor, all the scripts for that.
All right, we're going to go over the hardware design now. Just want to give you a high level of how the hardware works. It's basically divided into 3 separate circuits the way I see it. You have the one on the left, the one on your left, that's the power circuit. So that includes the battery itself, the charger for the battery, and the necessary components for it to power the Intel Edison microprocessor. The middle circuit is our micro SD card circuit, and then the one on the right is our GPS circuit. We chose to use the Intel Edison. It's a microprocessor module, and what I mean by that is it includes Bluetooth and Wi-Fi already on it. The reason that we chose to use this is because in order for us to be able to develop this product in 4 or 5 months to a working prototype, we needed to be able to cut out some of the other more high-speed switching problems that there would be designing your own Wi-Fi module, things like that. If you want to know the actual microprocessor itself, it's called the Intel Atom. That is in this module, as I said. And after everything communicates to the microprocessor, it can then communicate via Wi-Fi to your smartphone. Okay, so here we have the circuit design. The design for the circuit was taken from several subsection, like they were smaller pieces individually from other devices. We had to adapt them a little bit for our needs, obviously. I guess I'll start in the top left. There we go, top left. So that's your input, your USB Type B micro input. That goes to the next chip, which is the charger for the lithium polymer battery. And then the battery is denoted as just these 2 leads right here. And then that goes to your system power for the processor. This circuit right here you have the cage for the micro SD. The micro SD operates at a voltage level of 3.3, which is too high for our inputs on our microprocessor pins. We need 1.8 for the general purpose in and out and the UART communication pins. So we needed this voltage translator to step everything down. And then down here you have, this is the breakout for the GPS this is just a vertical connector to our GPS module that allows us to communicate with the processor. this is what we showed in our midterm presentation as our full board prototype. As you can see, it's pretty big, it's bulky, but we did have 100% functionality on it. This is our most recent implementation, which, as you can see, well, we can't see because they're small, but that's actual size. So it's a considerable, even if you take out the breadboard itself, it's a considerable size difference. The GPS antenna, we would in future implementations cut it and make it smaller. Obviously, the whole thing can become more compact. This is our first prototype PCB, not our final. We do plan on making this much smaller, especially because as we go forward, move forward with this product, we're going to be designing our own Wi-Fi module circuits and going straight from a microprocessor. We don't want to cut out. We plan on developing this after we graduate. We don't want to be using a whole Intel Edison module. That's really expensive. Suvro will do the software design.
So this is the high-level software architecture. On the left side, you have the Intel Edison Yocto Linux operating system. So this hosts all the startup modules. That means when you turn on the device, it acts as a Wi-Fi access point mode. So in your phone, it will show up as Euphony, as a Wi-Fi. Startup module also sets up the GPS module, like puts the RX and TX pin, enables them. And then the GPS module, of course, starts reading those values and feeding them to the smartphone operating system, which is in location module. And then the credential modules host all the password for the Wi-Fi connection. The SD card modules mounts the SD card to the device, to the microprocessor, and makes it available for the smartphone OS to access. And the change password module in the smartphone app right there reads from credentials module. So that's how they're connected. Then the music file server module is hosted by Apache, contains all the music files, gets all the ID3 data of the music, album art, song metadata, and then sends it to the media player of the smartphone OS, which in turn sends this to the HMI layer, which is the UI for the app. And then the watchdog module, what it does is, it's always waiting for a shoulder tap from the app. So if I say change password, it will know from the credentials module know, and then it will turn off the device and restart the Wi-Fi connection. So the user has to turn in using the new Wi-Fi password. And this is the more detail that I just talked about. So I'll hand over to Nick to talk about the HMI.
Alright, so here we have a nice little slide kind of displaying the evolution of the HMI. The right and the left are our initial screenshots from what we had gathered from other people's feedback. As you can see, the one on the left, is our original color scheme, which was just black and yellow. Some users thought came across as desperate. That's not what we intended. We wanted something that was user-friendly and nice to look at also. So then we have the right side, which we did not think was bold enough. It was a green, a mint green color. It just didn't look exactly how we wanted it to look. And our finished product in the middle is the Euphony green, and we've actually implemented that song album art blur in the background, which we think is a really nice touch. So expanding more on that, the top layer we have the header, where the user can sort by songs, artists, and albums. We plan on future implementation with genres and possibly playlists. In the middle layer, we have the songs list, where the active song is actually highlighted. Again, the background of the album art is displayed and blurred for a nice quick effect. And the song metadata is displayed. And that third layer is the actual media player, where we have the scrubber with all of the media controls, your play, pause, fast forward, stop, rewind. And at the very bottom, we have the ID3 data from the current track. It's the artist, the album name, and so on and so forth. Here we have the iOS development. I'm not sure how many of you are familiar with Apple's programming environment. I was able to use Xcode and the Apple Swift programming language to essentially create a single view web view application. As you can see, not everything is completely completely implemented. We still have a few tweaks here and there. On that right is the final screen that we have. We also implemented a splash screen. So as soon as you open the app, that is displayed. And it's kind of hard to see, but on that top screen, you can actually see the Euphony icon in the bottom right-hand corner.
And that's exciting for us because our original specs, we didn't specify that we were going to implement anything on Apple. We were specifically catering only to Android.
We felt as entering the marketplace, we needed to have both Android and iOS. So,
Okay, so I'm going to talk about major bug fixes, software-wise. The first bug was something that we didn't know why it was happening. So we spent hours of debugging because the first artist in the HMI was showing the songs under them, but the rest of them were not. And for the longest time, I couldn't figure out how this was happening. Turns out it was just the array that I was sending wasn't reading the basic value, wasn't reading. So it started from from 0 actually, JSON data instead of 1. And that's pretty basic, but this was a major bug, and we couldn't display this. We couldn't demo this without fixing it. So this was one of the major bugs that we fixed. The other bug that happened before this was the metadata in the media player wasn't changing, and that was due to the fact that it was looking at it was always looking at the first song in the playlist, or on the previous song in the playlist, as you can see. So right there, it was looking at this song rather than the current song. So we fixed that. Then last midterm, during midterm, we didn't have the GPS module working. We had some values, but so eventually we implemented the GPS module where, first of all, it was reading NMEA data, which was just this format. Then we converted it to the longitude, latitude, and then eventually, now it shows up in the app as the location. And if you actually tap on that value, it takes you to Google Maps and show you pinpoint where the device is. Now, you could ask if you lose the device and you walk away and the Wi-Fi connection disconnects, what happens? This value wouldn't change because the device is still there. You're just walking away from it, so it will still retain the last location that your device was. Now, if somebody grabbed that device from there and ran 100 miles, that would be really impossible to figure out in this situation. But you can always click on refresh to see the updated values of the GPS. Now, we also implemented change Wi-Fi password. So from the app, you can change the Wi-Fi password. And again, the watchdog module in the Intel Yocto operating system waits for that shoulder tap and then changes the password and then restarts the Wi-Fi connection. So just to make it secure.
So currently in our V model, we're someplace between system test and start of production. We do have a few tweaks here and there, but as Sean might have mentioned, we do want to continue on with this after we graduate. We want something that can be brought to the marketplace for all users to enjoy. So that's kind of where we're at, and we have some future tasks in order to do that.
So, again, we need to keep testing our PCB, which Nick has affectionately named Pizzazz 1.0. We're going to obviously explore miniaturization possibilities. Like I said, we need to get away from the Intel Edison module, make our own from a microprocessor. We would use a smaller one as well. And we need to evaluate other battery options. We didn't experiment with that too much this semester. And also, the GPS antenna works in wide open areas, but we want something that works really, really well inside buildings.
But we did get, for the battery option, we did get 4 to 5 hours of continuous play over Wi-Fi. So we want something more. And then the future tasks for software would be implementing the functions such as shuffle, just basic media player functions. Like playlists, you can have your own playlist, and then sort by genre.
And then on my end, I just want to continue developing the iOS software. We need to create an actual enclosure for the hardware. We are exploring patent opportunities, and we want to develop an aesthetic package for users to enjoy. So without further ado, we have the project demo, and we hope you enjoy.
So this is where the device is getting connected to the Wi-Fi, and we're loading the Android app, and it's syncing. It's syncing about 8 gigs of data in less than 10 seconds. So I just played the first song, and then I'm playing this next song. And you can see on the right that that's the device, Euphony device. Then the scrubber works fine, and towards the end, it's really yeah, you can go towards the end. Then it auto plays to the next song, and then you can change that song. And then again, Taylor Swift, because that's been always our highlight of our demos. So we wanted to do Taylor Swift music. So, and it's playing that song. And as you can see, I turned right, and then this screen, the Wi-Fi password changing screen, and the GPS screen showed up. But the music is still playing, so you're not losing out music, it's still playing in the background. And it's just as simple as that. And you can play pause,
Standard media player function.
standard
Play,
media, stop the
pause,
song,
stop, play.
and play again. And then I'm now going to show the autoplay, so it will go to the next song and starts playing Taylor Swift again. Again, a little bit back.
Again, we want to implement like a shuffle feature, so autoplay will actually shuffle to.
So it just went to the new song and started playing because that song ended. And then now we're going to demo that without USB power, or without power, it's working on the rechargeable battery. It's going to play another song. So it's working with the battery as well. And back to the song.
So yeah.
I'll just demo the forward and backward.
Alright. And we'd like to conclude with any questions you may have.
This is probably a simple question that you may have already stated, but where is the music stored?
In the device in the form of an SD card.
Micro SD.
Micro SD.
So the music's in the other device that's being played through your phone.
Correct.
So it's not actually stored on the phone or
Or using cellular data.
using your cellular data.
What would be your biggest tip for somebody wanting to do this? I know you overcame a lot of things. What would you think is the biggest thing for a lot of people?
Great question.
Great question. Computer networking class with Dr. Anaber actually really helped. That solved our problem of sending HTTP requests using Apache was really helpful for us to host the music files. And like it worked almost instantly. If you click on a song, touch a song, it starts playing. It's that fast, and that helped us. Instead of doing some other APIs, RESTful APIs, which also need internet. So that helped us.
I'd say another thing to add to that is kind of our overall team dynamic. We kind of had the goal at the beginning of the semester to have something at the end that we could, possibly market to everyone, and just having that same team end goal was really nice to share with everybody.
Another thing is, if you're planning on designing a PCB, start looking at how to do it now, and start printing them very early. It's a really long turnaround time to get them done. I would recommend not using Oshkart because, as Richard stated, he had some trouble with how they printed his board, and I also ran into some issues with them. So, just a side note, sort of.
Side note, the university can make print circuit boards if you need it.
What was the hardest part of developing the Azure app?
Changing password from the Android app in the Euphony device and getting it to work with the GPS too, so that when you turn right and then you have that menu, the page come up. That was that was because we had to get the GPS working first, and then port that over to the app was kind of hard, was kind of difficult. But we got it done like 2 weeks ago. Still got it done.
Mr. Chase.
How is your guys' music app different from something like iTunes or the Android equivalent of that? Like, why can't I just use the iTunes software to play music from a server that I have?
There's no direct interface to do so, so I don't believe that you would be able, through iTunes, to just...
Well, you're asking iTunes over data, right? Over cellular internet?
I mean, just in general. So your guys' software goes to the server, and streams the music onto the...
No, it actually does. So it's a local server. So it has Wi-Fi, right?
Right.
So it's connecting. It's not using any data. So
Right. Well,
it's,
right. So it's just streaming it over Wi-Fi.
yes.
So why can't I do that with iTunes and use the app server on my Linux?
might be able to do that, but this is specifically designed to interface with our device. I mean, iTunes isn't going to have a Find My Device tab on it either. So
Okay.
that's another part of it.
And also to add on that, if you don't want to use your cellular data, you'll need a Wi-Fi connection for things like iTunes or the Android equivalent. So if you're driving in your car or whatever, you want to stream your music via Bluetooth to your head unit, you have this connected via Wi-Fi, you're not using any cellular data at all.
So will your app cost money, or will it be free to
No.
whoever buys your?
So the apps will be free, but we will sell the device. That's how we generate it.
I will thank you guys for your time.